A very good day to one and all. I, Ashwant from the Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli, is presenting my paper titled KMetaTagger, a knowledge-centric, metadata-driven hybrid tag recommendation model encompassing machine intelligence. The co-authors for this paper are Dr. Gerard Deepak, Dr. Sheba Priyadarshini, and Dr. Santanu Vijayan. Abstract. The emergence of Web 3.0 has left very few tag recommendation structures compliant with this complex structure. In this paper, we propose KMetaTagger, a knowledge-centric, metadata-driven hybrid tag recommendation framework. We consider the CISI dataset as the input, from which we identify the most informative terms by applying term frequency inverse document frequency, the TF-IDF model. Topic modeling is done by latent semantic indexing, LSI. Apart from this, the metadata generation quantifies the exponential aggregation of real-world knowledge and is classified using gated recurrent units. The color harmony algorithm filters out the initial feasible solutions into optimal solutions. This advanced solution set is finalized into the tag space. These tags are recommended along with the document keywords. When the suggested K-meta-tagger's performance is compared to that of the baseline techniques, it is found to be far superior. Motivation. The World Wide Web is overflowing with data, and its structure is evolving towards Web 3.0, also known as the semantic web. There are not many techniques that are compliant with the semantic web for tag recommendation, owing to the structural complexity of Web 3.0. So, there is a dire need for newer novel methods with improved accuracy and reduced complexity for tag recommendation, which is compliant with the Web 3.0 standard. Tags are potential marker for organizing content on the World Wide Web. This organization allows retrieval systems, search engines, and other expert systems to understand, retrieve, and utilize these entities. Social awareness is largely essential to overcome the competitive disparity between the social web and the current World Wide Web framework. Contribution. This paper proposes a semantically driven document tag recommendation framework. GRUs are used to classify the metadata, and the semantic similarity of the classified instances is computed using agents under the color harmony metaheuristic optimization algorithm. Since machine intelligence is being used to improve the recommendation, the proposed model safe measure and fast discovery rate are better than the baseline models. Literature survey. Although several papers were used for literature survey, the three important papers have been discussed here. Kataria et al. Have proposed a two-stage method where in the first stage, corpus-wide topic-level information contained in the tags is exploited to model one layer of neural language model, and document-level word sequence information is used to model other layer of the proposed architecture. In the second stage, obtained document and tag recommendations are used to learn user representations. Hong et al. Have put forth a tag recommendation model using topic modeling approaches. Emphasis was placed on highest topics in calculating document similarity to retrieve more relevant documents. Document similarity and the historical tag occurrence was considered to calculate tag scores. Anarfi et al. Have proposed a reinforcement learning method to automatically recommend tags for mashups. This method carries out effective exploratory actions to automatically extract suitable combinations of tags for mashups through word vector similarities. The major gaps identified in these frameworks include absence of strong relevance computation mechanisms, absence of entity enrichment, and lack of diversity of the results. Proposed architecture. The TF-IDF model is applied over the document corpus of the dataset to indicate the number of most informative terms. At the end of TF-IDF, the extracted terms are subjected to LSI for topic modeling. The terms extracted from the dataset are then sent into a series of knowledge stores individually and separately. At the end of this phase, all this knowledge harvested in the form of entities as well as the topic model terms is all formalized into a form of an information network. Simultaneously, metadata generation from the real-world World Wide Web takes place using the Apache Tika. Classification of metadata is done using gated recurrent units. However, only 50% of the instances under each class are considered due to large volumes of the data generated. This 50% of the classified instances, based on random selection of classes using the upper concepts and random concepts, is used to compute the semantic similarity with the terms of the information network using an agent modeled using the agent's peak under the color harmony metaheuristic optimization algorithm. This advanced solution set is finalized into the tag space. These tags are recommended along with the document keywords, which are ensured for further alterations and verification by the domain experts of the community. Implementation. The language used was Python, the IDE used was Google Collaboratory IDE, and Apache Taka was the metadata extraction tool used. Dataset. The dataset used was the CISI document dataset. It is a text-based dataset made publicly available by the University of Glasgow. The Center for Inventions and Scientific Information acquired the textual data for 1,460 documents and 112 associated queries. Its objective is to be used to develop information retrieval models that provide a collection of document IDs that are pertinent to a specific input. The proposed KMetaTagger was implemented using Google's Collaboratory IDE in an Intel Core i7 computer with a RAM of 32 GB and a clock speed of 3.6 GHz. Google's knowledge bases were used either by encompassing the API directly or by means of specific query. Result analysis. Precision, recall, accuracy, F-measure, and false discovery rate are the major measures which are used for the comparison of the performance of the proposed KMetaTagger with respect to the other models. The proposed KMetaTagger yields the highest average precision of 96.27%, the highest average recall of 98.07%, the highest average accuracy of 97.17%, the highest average F-measure of 97.16%, and the lowest FTR of 0.04. The precision, recall, accuracy, and F-measure compares the relevance of the results, whereas the FTR computes the number of false positives yielded by the framework. The proposed KMetaTagger yields the best performance because it hybridizes several models like the TF-IDF and LSI for topic modeling. Topic modeling ensures the density of the hidden topics is modeled into the framework. Besides enriching the topics into the framework, knowledge is incorporated from 4 distinct sources: CYC, LOD Cloud, Wikidata, and DBpedia. This knowledge incorporation ensures that the aggregation of knowledge and the enrichment of entities from several real-world sources. A heterogeneous information network is formalized, which increases the diversity and the density of auxiliary knowledge. Apart from this, the metadata generation quantifies the exponential aggregation of real-world knowledge and its classification using gated recurrent units. Computation of semantic similarity using semantosim, KL divergence, and heap evenness index with differential thresholds and step deviation also enhances the relevance of the results, and its refinement by applying the color harmony algorithm. It filters out the initial feasible solution into optimal solutions, ensuring that the model yields the best possible tags with significant relevance to the model, with a high amount of diversification and enrichment of the auxiliary knowledge. The DR-CBTR model does not perform as expected because of lack of enhancement of magnification of knowledge from external knowledge sources into the model and the absence of strong relevance computation mechanism. The TMA model does not perform as expected because of the absence of entity enrichment, because relying on topic modeling alone does not enhance the diversity of density tags. The RMTR model does not perform as expected because of the lack of diversity of results and strong relevance computation mechanisms. Practically implementing the entire World Wide Web data by learning is computationally cumbersome. The hybridization of SVM, cosine, and the LDA model also does not perform as expected because SVM is a conventional binary linear classifier and cosine similarity is a naive semantic similarity classifier computation scheme. Furthermore, topic instant enrichment also does not occur. Performance analysis. This figure shows precision percentage versus the number of recommendations over a range of 10 to 50 recommendations for KMetaTagger and other baseline models. It can be clearly seen that the KMetaTagger yields the highest precision percentage for this range of recommendations. Conclusion. The outcomes obtained prove the adequacy of the proposed model for intended purposes. The proposed KMetaTagger achieves the highest average accuracy of 97.17% and the highest average F-measure of 97.16% among the models compared, implying that it is by far the most effective solution. The high accuracy in F-measure accomplished is due to several models like TF-IDF and LSI for topic modeling and the usage of the color harmony meta-heuristic optimization algorithm to convert the initial solution set into a more refined and feasible solution set. In order to increase the effectiveness of the model, additional meta-heuristic algorithm integration will be looked into the future as a part of the work's future scope. References. These are the references used for the paper. Finally, I would like to thank everyone for providing me this opportunity to present my paper.